In this video, we are going to be factoring a difference of squares. A difference of squares occurs when two binomials multiply together that have the same letters and variables but different signs. Factoring using this method is really easy, but your equation or expression needs to follow these certain rules in order for it to work. The first rule is it has to have only two terms in it. So a good example of something that has just two terms would be x plus 2x. That has only two terms. That would work. That's the first thing we can look at. But then that also has to meet the second criteria or the second rule, which is it has to be a perfect square. Both terms have to be perfect squares. If you look at the x plus 2x, both are not perfect squares because 2x is not x is not a perfect square, right? We can't say x times x is going to give us something. And remember, perfect squares is pretty much something that you can take out the square root of and get a whole number, right? Perfect squares would be things like x to the 2 or x to the 4. We can square root that because remember, square rooting x to the 2 will get rid of the 2, right? And then square rooting x to the 4 would be x to the 2, right? Things like that would be perfect squares. And perfect whole numbers would be your 4s. We have 4, we have 16, right? We have 25. Things like this are perfect squares, so we need them to be perfect squares. And the last condition is the second term must be negative. So on up top over here, we had x plus 2x. But for it to be a perfect square, for it to meet the criteria of a difference of squares, this has to be a negative and these two have to be perfect squares. Though it's two terms, right? Okay, so these are the criterias. Now I'm going to show you a bunch of questions and I want you to try and figure out which one this method is going to work for. You don't need to solve anything. We're going to solve in the next phase. Here are the expressions. Look at each one of them and just simply tell me which one is a difference of squares. Which one can we use this method for? Remember our rules on the last page there. Must have two terms, must be a perfect square, and the second term must be a negative. So pause the video if you need to. Okay, the first one, x squared minus 16. This is a perfect square, so I'm going to put a check mark beside it. Why is it a perfect square? Because we have x squared. And if you remember from our last slide here, x squared is a perfect square, right? Because the square root is going to cancel out, and then you're going to be left with an x. So x squared is a perfect square. 16 is a perfect square, right? Because the square root of 16 is 4. It's a whole number. And our last criteria said that the second term must be a negative. So that's a negative. That checks out. This next term, 2x plus 25, is not going to work for factoring of difference of squares. Why? Because it's 2x plus 25. What's the difference? 2x is not a perfect square. It has two terms. That checks that first rule off. It has 25 is a perfect square, but 2x is not, and both terms have to be perfect squares. Plus, this has a positive anyway, not a negative, so it's not going to work for this method. The next question is 2x minus 25. This one, again, is not a perfect square. It's pretty similar to this one up here, but this one is 2x minus 25. 2x is, again, not a perfect square. Though it has a negative and 25 is a perfect square, one criteria is not met, so none of this is gonna, that expression is not gonna work. The next one, we have 5y minus 72. Is this a perfect square? No, it's not. Why? Because there are no perfect squares. The next one is x squared plus x minus 2. This is not a perfect square, so we're going to put an x on that one. Why is it not a perfect square? Again, it has 3 terms, right? It has 3 terms. We have term 1 right here, term 2, and term 3. And if you remember, terms are divided by positives and negative signs. So this is not a perfect square. It doesn't meet the first criteria. We don't even look at it. The second one, or the second to the last one, is 16x squared minus 25y3. Now let's look at this. 16 is a perfect square. X squared is a perfect square because this would give you 4x, right? So those are perfect squares. 25 is a perfect square. 25 is a perfect square. Y to the 3, however, is not a perfect square, right? Because we can't square root 3. We can't square root 3. It's going to give us we're going to end up with a remainder somewhere. So we can't really do that. So y to the 3 is not a perfect square. So this equation will not work. So this one is a no-no. Now the last equation, it's really similar to the top one. We have 16x squared minus 25y squared. This works. This is a check mark. This is a perfect square. This is a difference of squares because we have the first criteria is met, right? There are 2 terms, check. Both terms are perfect squares. 16 is a perfect square with a 4. X squared is a perfect square with an x. 25 is a perfect square, and y squared is a perfect square. So those are perfect squares. Okay, so now we're going to get into examples and actually factoring these expressions. So the first thing is to check if it follows your rule. These 2 do, so we're going to move on. Then the second step is to square root both sides. Square root both sides and put your square roots in brackets. So the easiest way to do this, we're going to have 2 brackets, right? We're going to have 2 brackets. Now for x squared, what's x squared? X squared is also, it's the same as writing x times x. It's the same as writing x times x, right? How about 16? 16 is the same as saying 4 times 4. So now we're going to put each of these into each bracket. So we're going to put 1x into one bracket, so this x, and then the second x into the other bracket. Then we're going to put 1 4 into one bracket and the second 4 into the other bracket. And what's left, how do we know the signs? You're just going to use opposite signs. You're going to use positive and negative. It doesn't matter what order you do it. It just doesn't matter. You're just going to put positive somewhere and you're going to put a negative somewhere. So I'm going to have plus and minus, and that is your final answer. This is your final answer right here. You have x plus 4, x minus 4. That is your final answer. Seems pretty easy to me. We're going to do this question, and then I'm going to give you a couple of questions to try on your own and see if you got it. We have, for this question, you have 16x squared minus 25y squared. Follows the criteria. This is going to be written as 4 times 4 times x, right? Subtract 5 times 5 times y times y. Okay, so we're going to have 2 brackets. 4x, so we're going to bring this 2, because this is still the same term, right? So this is going to be written as 4x. Again, the last 4x's we're going to put in the other bracket. Again, opposite signs. Again, 5y come in this bracket. 5y, the second 5y in the other bracket. That would be your final answer. Doesn't seem as colorful as the first one, though. So how about check? So we are done. We want to check out our work, right? You can check to see if this is correct. And the best way is to use the FOIL method. I'm going to quickly go over. This means firsts, outers or outliers or whatever you want to call them, inside, and lasts. So what that simply means, you're going to go multiply the firsts. Then you're going to multiply the two outer ones, which is x and 4, right? Those are the two ones in the outside. So I'm just going to change the color here. So we have x times x. Those are the firsts. We're going to get x squared. All right. Then our outers are x and 4. Those are the ones at the outermost part. So we're going to x and 4, which is going to give us minus 4x. Right? And then our insides, which is the 4 and the x, which is going to give us plus 4x. And then our lasts. So the lasts for both terms would be 4 times 4, which is negative 16. Now, to just fully solve that, we're going to end up with x squared. This is going to cancel out, right? We have negative x squared plus positive 4x cancel out, and we're going to get a 0 there and then negative 16. Checks out. Checks out. We're going to do the same for this question. 4x times 4x would be 16x squared, right? Again, 4x times negative 5y would be negative 20xy, plus 5y times 4x would be positive 20 xy or yx, doesn't really matter. And then I'm going to run out of room here, but 5y minus 5y would be negative 25y. Again, these two will cancel each other out because you're similar, and we're going to be left with 16x squared minus 25y. Again, checks out, same at the top, we're good to go. Here are two questions that you should try. Pause the video and try them out. Okay, so let's do them together. We have 100x to the 16 minus 4. One thing to keep in mind when we're doing exponents, to find the squared of whatever it is, it's not necessarily the square root. Because if I took the square root of 16, it would be a 4. But that is not how we do the exponents. The answer would be 8. It would be, what can you add together to give you that exponent? So for this question right here, where we have x 16, the 16 is going to be the perfect square, or the square of 16 would be 8, not a 4. Something to keep in mind. So we're going to have 100, which is a 10 for sure. And x to the 16 would be x8 for both sides, x8, not x4. And then we're going to have different signs, positive, negative. 4 is pretty simple. That would be a 2 and a 2. The final answer. If we were to go to check our work, we're going to have 10x8 multiply 10x8. Again, 10 times 10 is 100. x8 times x8. When you're multiplying exponents with the same with the same base or with the same coefficient, you add the exponents, right? So 8 plus 8 would be 16. So we've got x 16. And then we're going to do 10x squared multiply negative 2. And that's going to be negative 20x8. Again, this would be positive 20x8. 8, and then whereas before, again, these will cancel out. We have 10, 16 minus 4. 100, sorry. 100 x 16 minus 4. This checks. This is our final answer. Let's do the second one. We have this, which is 12. We're going to have two brackets again. 12 in here, 12 in here. This would be y. Right, again, different signs. Choose a different color. positive, negative. 6 to 4, y to the 4 is exact same thing, like 8y squared, 8y squared. Now again, if we're to go to check, we're going to get the top answer. So that is it for this video. See you next time. Have a good day. Bye.